Okay, so we have a boy and a girl pushing off of each other, and the boy in this particular situation has more mass. So he has more mass, she has a smaller mass. They push off of each other, and originally they were both at rest. Who felt the greater force? Well, this is a little bit weird, but if you remember back at the beginning of the year, we talked about Newton's third law. They would actually both feel the same force. And I think that doesn't make any sense. Remember the situation we talked about where a bug hits a windshield, and I asked you which one felt more force? Well, the bug and the windshield actually both feel the same force. The reason the bug becomes splattered and falls apart and the windshield barely notices is the bug has a very tiny mass and the windshield has a very large mass, so they have different accelerations. Really similar situation here. We got the same force, but the girl is going to experience it a little bit more because she has a smaller mass. Who would feel the greater change in momentum? Same idea. His change in momentum would be the same as her change in momentum. They're not going to experience it the same way because they have different momentum. They have different masses. So if afterward she has the same momentum as him, they both started from 0 and now they have the same momentum, they're not going to act the same, however, because she has a smaller mass, he has a larger mass. So she's going to have a larger velocity to compensate for that. He's going to have a smaller velocity. But their momentums and their change in momentums will be the same in this situation.